Are we alone? That single question propels our journey today. We're venturing beyond our solar system, asking, can life exist on exoplanets? Join us for a deep dive into the science of habitability, exploring the crucial factors that might make a world home to life. From the Goldilocks zone to atmospheric signatures, we'll uncover the latest research and the thrilling possibilities of extraterrestrial existence. Let's explore the cosmos together. An exoplanet is any planet orbiting a star other than the Sun. As a result, the universe would probably contain many trillions of them. However, what we have discovered about exoplanets goes against any realistic likelihood of ever finding a life-bearing exoplanet. In fact, most suggestions and positive talk is more wishful thinking than actual science. Also known as the habitable zone, this is the area around a star with the temperature can be just right for liquid water to exist on a planetary surface. For example, the Earth exists within the Sun's Goldilocks zone. With larger, brighter stars, this zone is larger and further away from the star. With smaller, dimmer stars, it is smaller and closer to the star. When it comes to red dwarf stars, in many cases they are so dim that the habitable zone is closer to the star than the orbit of the planet Mercury. A good example of this can be found in the system called T1. This system has 7 known planets, all of which are way within the orbital distance of Mercury from the Sun, including a very narrow habitable zone. One of the consequences of being so close to the star is that the planets would tend to be tidally locked like Mercury is. If there is any water on the planet, it would tend to create what is referred to as an eyeball Earth, where all of the water is pulled to one side by tidal forces. However, in either case the planet would be too cold and dry on one side and nearer at the boiling point of water on the other, with the atmosphere possibly even exceeding it. While there does exist some forms of life here on Earth in some pretty extreme conditions, such extremophiles are the exception rather than the rule. Based on computer simulations, it is claimed that life could exist in the temperate zones of these planets. The problem that is completely ignored is that these temperate zones would be filled with horrific currents in the atmosphere causing storms. There would probably also be strong currents in any water, as well making it impossible to stay in the temperate zone. This makes the likelihood of finding life on such planets wishful thinking at best. The simple fact of the matter remains that none of the exoplanets that we have actually observed show any real evidence of being habitable. Most of them are large planets close to their stars or smaller planets close to their stars under situations where it is highly unlikely that life could survive even if you put it there. The problem is that at least the exoplanets we have discovered give every evidence of being completely inhospitable to life. So, is it possible to have a habitable exoplanet? Of course, a planet similar enough to Earth would probably qualify. The problem is that the exosolar planets that we have actually observed are more likely than not uninhabitable because of the conditions that they exist under. If life did exist on an exoplanet, because of the distance it would be difficult to find. This is because in most cases we do not observe these planets directly, but by the influence they have on their star or its light. It is in the latter case where hints of life could be found in the starlight coming through the atmosphere of an exoplanet. The answer to this question is probably none. The planets most likely to have life on them would have thin atmospheres, making actual life signals hard to detect. The second problem is that a lot of the chemicals that would be possibilities also have non-biological origins. The point is that we have to be extremely careful that we declare having found something too soon. It has happened before, because some people are too eager. In conclusion, can life exist on exoplanets? Yes, it is possible, but we really have not found any that are really candidates. They tend to be too close to their whole star to really be likely to be habitable. So, while it's possible, there are most likely not any within a distance that we could actually detect. If you like this content, don't forget to give it a thumbs up and subscribe. Also, please help support this channel. See the description for details.